Alright, in here, simple averages, a simple averages assumes the same number of each object. And a weighted average takes into account that, I would say account the fact that we do not have equal numbers of all objects. Okay? So how do we calculate weighted average? So that's the difference between simple averages and weighted averages. Now the question is, how do we calculate weighted average? So I'm going to write and then we'll work on example. So weighted average is calculated by multiplying the percentage of the object by its mass of each object So first percentage we convert into decimals and then you add them. Then adding the numbers together. So that's the procedure. Alright, so now we are going to work on one example. So that way we know that, okay, that's how we calculate weighted averages. Alright, so we know how to work on average, simple average, but we are calculating weighted average in order to find out the isotopes. So let's take an example. Okay, let's say for example gallium has 2 isotopes. You found 2 gallium in a nature. Gallium has 2 isotopes. (69Ga) with mass of 68.926 AMU and 60.11% in abundance. That's the first, 69Ga. And the second one, it's 71 gallium with mass of 70.925 AMU and 39.89% abundance. Now we need to calculate average atomic mass.
What is the word after the percent?
Abundance.
Is that 897? What is it? 891?
89%.
percentages.
Oh,
And we need to find the average atomic mass. Of A. That's the one we need to find. Okay? So I am going to organize this information, the one we have, 68.926, and this information in a table form. So that way you can utilize it. So let me organize in a next slide, and then I'll tell you what to do. Alright? So
Can you
you
go back?
have
Can you go back?
GA, hold on, I will go back. I'm going to write all this information here. GA 69
No, I need the last one.
and GA 71.
Find the
I have that.
You have given AMU 68.926 and 70.925. That's the atomic mass. You have given percentages. You have given percentages, 60.11 percentages and 39.89 percentages. So we transfer this information in a table form. Alright? Then what we do? First, the percentages you have, you divide by 100, you convert into decimals. Alright? So when you convert percentages to decimals, you get 0.6011 and 0.3989. Okay. So now you have AMU times this percentages you convert, you multiply those together for GA 69, alright. So when you multiply those two numbers and then you add them with these two numbers, so I'm going to write that, okay. What you can do, 68.926 times 0.6011, and then I'm going to adding sign 70.925 times 0.3989. Remember, we are adding those together, okay. And when you calculate and add those together, let me place the equal here, you get 69.72 AMU. So that's average atomic mass of gallium. You calculate weighted averages of these isotopes.